Has an hour of time ever just disappeared right in front of you? Well, my brother, best friend, and roommate Zach has it happen a bit too often. Why is it such a problem? Well, somewhere between the daily urgent bug fixes, onslaught of notifications, and several back-to-back meetings, he forgets to log his time. Zach's currently working from home, and he's one of the best at what he does, but performance metrics can be hard to track at his company, so he has to submit a timesheet at the end of every week in order to get paid. I think you and I are both seeing the obvious problem here. Zach has the most honest, caring work ethic of anyone I know. And that's an unbiased opinion, of course. However, he's missing out on a lot of pay due to his timesheet looking more patchy than Swiss cheese. Even if he grinds 50 hours one week, Zach ends up spending 2 more of his own time on Friday night just trying to scrape together a 40-hour total before the timesheet is due. The situation got my mind spinning up ideas. How could I reinvent Zach's time entry to bring a bit of stability back to his week, get him paid for the hard work he puts in, and also save him from that disappointing walk back into the office on Friday night? Let's talk requirements. Since this is a very purpose-built project, we have to tailor our requirements to Zach's needs. First off, the solution shouldn't just be a pop-up or general notification. They're just way too easy to dismiss, click, they're gone, you forget about them. And also, if he's sharing his screen, he doesn't want anything showing up for other people on the meeting. Also, we can't have an auditory-based solution only. He likes to wear his headphones because they're comfortable, but they might not always be plugged in, so being solely reliant on that isn't going to work. Furthermore, and very importantly, we cannot unintentionally distract any of his coworkers, so we can't do anything that would be moving around on camera or any loud noises that get picked up by his mic on meetings. I had a fun idea to use a wristwatch that would buzz whenever he had to enter his time, but he finds watches and wearables uncomfortable while programming for a long period of time, so that's a no-go as well. As an added requirement, I want to integrate some sort of gamification into the product because it's really easy to lose sight of what you're trying to do, but when you integrate some sort of fun experience with it and make it so that you're excited or emotionally driven to interact with it, the product just becomes that much more effective. And I also challenge myself to build this with just scrap hardware I have lying around and only in a couple of days. So let's see what I came up with. If we power up a microcontroller like this one and connect it to a cheap OLED screen, we can very easily build out a basic timer. However, a basic timer alone is not going to be enough to get Zach's attention and keep him on track. So for that, we will also connect up a couple LEDs for status visibility, buttons and an encoder for user interaction, and potentially even a servo that literally waves at you to get your attention when you're behind on logging your time. How do I see this all working together? Well, I'm picturing we have 3 operating modes: idle, running, and alerting. We might even add some extra modes on top of that for settings and animations. Our microcontroller is going to be the brains of the operation. It's going to tell us when we're in idle, when we're in running, or when we're in alerting. Furthermore, it's going to handle all the settings and animation. Our display is going to have the job of, displaying what's currently happening. So it'll show us what mode we're in and what exactly is happening in that mode. Now, the interaction with the device is going to be handled by our button and encoder. They'll both talk directly to our controller and let it know what we want to do. Lastly, we just have our fun visual elements. That, of course, includes our LEDs and our servo. I think the servo will also add an audio element as well, but I don't think it'll be enough to get picked up by his mic, so I think we're all good there. With the interaction elements as input and the visual elements as output, we basically have our whole system. Now, all we have to do is figure out how we want to program it. Here, I have what I like to call a VMVP, or in other words, a very minimal viable product. It aims to have all the essential functionality without worrying too much, or really at all, about form. So if I press the encoder here, we enter into a setting state where I can change our timer value. Let's put it at 1 minute for demonstration. Here, we're in the idle screen, and when I press the button, we'll go into the running state. When the timer reaches 0, we enter into the alerting state. And when our grace period is up, which is currently set to 30 seconds, it'll start waving its hand at us to log our time. He's now had the prototype for over a week, and not only did he say that it satisfied all the requirements, but he logged 40 hours before Friday finished. Now, could this just be beginner's luck, using a new tool, having something different in your workflow? Sure. But it also shows that there is promise. I honestly considered just leaving the project where it is now, but that would be far too lame. So I decided to hop into CAD and get a final product design figured out. However, really quick, I did add a second screen to the setup, meaning using this walkWe animator to generate C code and the awesomeness of I2C addressing. We can have our settings and animation on one screen and all the information for our important timer flow on the other. In my projects, I always find it easier to model the components I'm going to be using first, such as our encoder, our servo, and the board that we're going to solder everything to. And then you build the enclosures or mechanisms all around it. Not only does it show you how you can better utilize your space and allow the components to work together well, but now you have reusable components that you can just basically drag and drop into different projects whenever you need them in the future. To be honest, like I generally do when I'm making projects for other people, I spent a bit more time on this than I expected. Hopefully you like the look of it as much as I do. Now just print everything out and get it assembled. That unfortunately includes soldering this rat's nest to a dedicated perf board. Now flip it on. Awesome. I made the hole too big. And I present the TimeBuddy. I'm currently powering the device off of USB-C, but of course we can use that 5-volt barrel jack in the back with a power switch. So we start out with the idle state with the interval time and last shriek being shown, as well as a very unamused, just hanging out face. And if I want to change any settings, I can click on the encoder and adjust whatever settings I want. For example, I can change the LED brightness or set a new interval time, which will just make 30 seconds. When I press start, we'll see the state change on the main screen, as well as the LED bar go green, letting us know that we're in the running state. When I go back to the animations on the right screen, we can also see we've shifted over to a nice little happy face because we're making money right now. Whenever the user presses the top button, we will reset the timer, implying that the user has entered their time. Whenever we press the bottom button, we'll leave back and go to the idle state. I'm gonna go ahead and back into the running mode, and we're gonna let it run out to 0 and see what happens. Now that we've hit 0, we can see the status change. Our TimeBuddy gets all sad. And of course, the LED bar goes red. But we both know it gets really serious when our grace period is up and we hit negative 30 seconds. We should probably get that. I want to show another setting that's really helpful as well if you need to log your time directly on a 30-minute mark or something like that, which is the continuous setting. If I flip this to on, then whenever the timer runs out, we'll start a new timer in the background, which will become our starting point whenever we reset. So we can see not only do we have the overdue counter now, but we also have our next reset timer. Clicking this top reset button when we hit 18, we'll see that we start our next timer from 18 seconds. In that final setting for launch, enable, and disable, we'll see why that's there very soon. I tried keeping everything relatively simple. I mean, it would be easy enough to set up an API to a software like Toggle for historical data tracking or do some sort of visualization on the device itself, but for our initial requirements, I think this satisfies it. However, it begs the question, is this enough? Is it enough to bring happiness back into Zach's workday? Enough to get him properly paid? Enough to make me feel like I can call this thing finished? No. So then how can we push this project over that line from simply okay to Shark Tank ready? Well, I'm thinking we rely on some well-known psychological principles and marry them with fun engineering design. Perhaps you've heard of reinforcement learning before. If you haven't, it's a relatively simple concept that just states by observing an agent, or in our case Zach, and allowing him to interact with his environment, or in this scenario the TimeBuddy, we can reward his behavior depending on what he does in that environment. Say, for example, staying on top of his time entries. In doing this, we can influence the way he behaves in the future, but how do we reward a content, hardworking man like my brother? Well, I'm thinking with a challenge and some sugar. Using some more scrap components, I'm betting we can figure out a way to mount an M&M launcher behind his monitors. I was initially going to create a roller wheel type mechanism, kind of like those motorized Nerf blasters, but I didn't like the idea of spin up and spin down time since we're only shooting off one candy at a time. So then I was thinking about taking a servo and making a small gearbox and then attaching an arm to it to throw the M&M, kind of like you would with your own floppy human arm. But it sounds kind of annoying to control and design. That brought me to the idea of spring loading, where we could use a servo to sort of cock back a spring-loaded platform, But again, there's a lot of added stress there and complexity that just doesn't need to be there. And then, suddenly, everything made sense when I caught the glint of an old solenoid out of the corner of my eye. I thought I could just load M&Ms onto the plunger directly and then basically push it into the air. However, the small 15mm travel distance and the low power of the device transferred an underwhelming amount of velocity to the candy. But the testing was not wasted. It gave me the idea to design a small rack and pinion mechanism where the linear motion of the solenoid would actuate the rack and the pinion gear would have a small arm attached to it capable of carrying a single M&M, more like a catapult. Not wanting Zach to have to manually load each candy, I designed a loading arm that uses a servo and some neat geometry to shuffle around ammunition inside of the hopper every time it moves back and forth. This helped me avoid any jams like this one right here 9 out of 10 times, and on the 10th time when it did miss an M&M, it would shuffle and then get it on the next one. There are other more common solutions to dealing with the annoying shape of M&Ms, which are oblate spheroids in case anyone cared, but this will work just fine for our use case. I modeled all the final components, including a way to mount the launcher to his monitor arm, wired up a cool basic circuit that uses a logic level MOSFET to help our second ESP32 control the solenoid, programmed the controller to use ESP Now for wireless communication with the TimeBuddy, and got everything assembled up. And now, either when pressing the onboard button or when notifying the TimeBuddy that we've submitted our time by pressing the reset button, the launcher will get wirelessly signaled to send an M&M into the air and hopefully end up in someone's mouth. Otherwise, the 5-second rule still applies.
Oh no! That's crazy.
Alright, it seems my calculations were a bit off. Let's add a travel stopper to adjust the flight path to something a bit more approachable. There we go. And now, we just sit back, watch the completed timesheets get submitted, and watch the money roll in. And more importantly, hopefully we can put a smile back on Zach's face where time tracking has taken it away in the past.